I'm going to make 3 videos about hypothesis tests for proportions and then 3 for sample means. I'm going to do a right tail, a left tail, and a 2-tail test for both. So let's go ahead and jump in and do this for some sample and population proportions. So a nutritionist claims fewer than 35% of teenagers eat breakfast daily. A sample of 220 teenagers found 66 who do. We're going to test that claim at a 5% alpha, a 0.05 alpha. So this is going to be a proportion problem because my data was given to you in percent form. And this is a categorical variable, yes or no, do they eat breakfast? So step 1 is we need to build our hypothesis statements and determine the tail. So a nutritionist claims that fewer than 35% of teenagers eat breakfast. So our actual, what we think is true right now, is that the proportion of teenagers who eat breakfast is 0.35. This researcher believes, or this nutritionist believes, that it's actually smaller than that. So what we believe right now is that it's at 35%. And since it's a fewer problem, we're going to use the left less than sign. And whenever we use the left less than sign in an alternate hypothesis, we are going to be doing a left-tailed test. Because we want to find out, is it actually more likely that the proportion of teenagers who eat breakfast is less or lower than what we think is true, 35%. After we get our hypothesis test up here, we need to go grab P, the standard deviation of P, and P hat, our sample proportion. Our population P is going to be the null hypothesis that we're testing, that 35% of teenagers eat breakfast. In order to get the standard deviation for a proportion, we're going to take our population proportion times 1 minus the population proportion over the sample size of 220, and all of that's underneath the square root sign. So square root of 0.35 times 1 minus 0.35, and all of that's divided by 220. So we will get a standard deviation of 0.032157. I'm always going to grab 5 or 6 numbers. P hat is your sample proportion. So we need to go find our sample information up in the problem, and we're going to use those numbers to create the proportion of the sample that eat breakfast. Since we're testing if they eat breakfast in the null hypothesis, our sample proportion also has to be about who's eating breakfast. So 66 divided by 220, we will get a P hat of 0.3. We now have everything we need in order to go find our z-score, or z-statistic. When we're dealing with sample and population proportions, we take P hat minus the population proportion that we think is true, the null hypothesis, divided by the standard deviation. 0.3 minus 0.35 divided by the standard deviation, 0.03157, or sorry, 0.03257. And I will get a z-score of negative 1.5549. Now that I have my z-score or z-statistic, we now are going to go take that over to our spreadsheets. And since we already identified that this is a left tail test, I'm going to go find the left tail. And once I have the tail of the test that we identified, we can also call this the p-value. So once I find the left tail from this z-score using a spreadsheet, since we identified this as a left tail test, my left tail becomes my p-value. So now I'm going to take that negative, let me write this down real quick, negative 1.5549. I always forget. Okay. So in my spreadsheet, I have a z-score of negative 1.5549. To get the left tail, I'm going to type in equals norm.s.dist should pop up. And I'm going to click on my z-score and hit enter. And since this is a left tail test, that's the only number I need. I'm not even going to worry about the right tail for now, 0.0599. So that'll round up to what, 0.06? Yep. So my left tail, or my p-value, is 0.06. Since this is a left tail test, my left tail is my p-value. So now we can decide if we should reject or fail to reject the null hypothesis. My p-value is larger than the alpha that we're testing. If your p-value is larger than the alpha, we fail to reject the null hypothesis, and we will continue to believe that the portion of teenagers that eat breakfast is 35%. This is the sample that we took in the test, the hypothesis test, was not significantly significant for us to reject it. So if our p-value is larger than our alpha, which it is in this case, we fail to reject the null hypothesis.